Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to this channel and leave a like for this video. Now, in today's lesson, we continue with set theory, and basically, I left this question in our previous lesson, and that is what we're going to start with. Then I'll give you these. Okay, from these, I'll solve one, then I'll give you the rest of the two to work out by yourselves. Then we'll see how we go on from there. So now, for this question, what you were supposed to note is, first of all, the intersections. We have intersection here, and intersection there. So now, what we know about intersections is that they are associative, right? That is, if you have A intersection B, this is equal to B intersection A. Same applies for the unions. If you have A union B, this is the same thing as B union A. And now for the association part, if you have A intersection B intersection C, we have intersections there. This can be associated as A intersection, open brackets, B intersection C. Okay. These are commutative. That is, A intersection B is commutative. Then if we have intersection throughout, they are associative. We can start with A intersection B, or we can start with B intersection C, then intersection A. The same applies for unions. If unions, A union B, union C, so these are unions throughout. So this can be written as, we can start with A, or we can start as A union B union C. So that is the association law. Then there's also the distribution law. Just give you the distributive law. That is, if you have, let's say, A union B intersection C. Now we see that they are different here, so we cannot use the association law here. So since they are different, we can distribute this value that is outside here. So we can say this value will be distributing as a pair like that. So it will be A union B here. Then what is here is intersection. So we put intersection like that. Then A union C. So that is the distribution law. The same applies if we had, let's say, A intersection B union C. So here, since these are different, we cannot use the associative law, but we know that this can be distributed as A intersection B union A section C, right? So those are the laws that you should know, right? So I hope you've written them down and taken note of them. So we're going to apply them now here. Okay. So now for this part, we know that we can associate it. So we can start with this part. We know that association can work here. The commutative can work here. So for this part, the commutative part can be written as A intersection. So we commute this. This is the same thing as A complement intersection B union C. Okay, so that is an intersection B complement. Okay, so commutative here can work like that. So we can associate this. We can start with this and this. So this is going as a group. We can't take it as one, as separate. So this is going as group. So B union C intersection A complement is the same thing as A complement intersection B union C. Remember that commutative law. If you have A union B, it's the same thing as B union A. And if you have A intersection B, the same thing as B intersection A. Okay, so this is what we've applied here. So B union C intersection A complement is the same thing as A complement intersection B union C. Now here we have intersection and intersection here. So these two parts can be grouped, or they can be, these three parts can be associated, so to say. So this can be written as A intersection A complement, like this, then intersection B union C. That, and outside we have intersection B complement. Okay, and now A intersection A complement. Okay, remember from the rules, A intersection A complement is an empty set, because you are getting A. What is in A? What does what is in A and what is outside A have in common? Well, they won't have anything in common. What is in A and what is outside A, they won't have anything in common. So that is empty set. So this part is an empty set. So we say empty set intersection B union B intersection B complement. Okay. Then for this part, again, we can do the association. So we can start with this one. So empty set intersection B union C. Well, we know that every set has an empty set as its subset. So basically, empty set and any set, they will have in common an empty set. So this will give us empty set intersection B complement. Okay. Then again here, empty set intersection B complement. Every set has an empty set as a subset. So what is in common between B and an empty set will be an empty set. So that is how you were supposed to work out this question. Now we are going to look at these questions. So you can just write it down and try to go through it by yourself, so that work out you are acquainted with it. Okay. All right. So we come to this question. We have A complement, A intersection B complement, then everything complement. So for this one, first thing that you should remember is De Morgan's law. Remember De Morgan's law. We have A intersection B complement. If you want to get the complement inside, then it will be A complement. Then the operation there changes from intersection to union, or from union to intersection, depending. So there it changes, then comes B complement. So this is what you should note. Another thing that you should note is when you have A complement and complement, this is basically equal to A. So A complement basically equal to A. Okay. So the idea here is that if you have a set A like this, so if this is the set A complement will be outside here. Okay. That is the first operation. But the complement of the outside will just be the inside here. So you get back in the inside. So A complement, the complement cancels out and just becomes A like that. Okay. So yeah, so basically that's that. Then so that is what you should remember. So now back to the question. So for this one, we can take the complement inside. So there is this complement, we can take it in. Just zoom it in. That, so we can take in the complement. That, so this will be equal to, so the complement goes in. So it will start with this part. It will be A complement. Then this will change to intersection. Then this will be A intersection B complement. Okay. Now A complement is basically A intersection just be A intersection B. Okay. Now we have intersection here. We can use here law, that is this can be written as A intersection A like that, section B. that, then this will be equal to what does A and A have in common? In section there just be A, the section B. So that is answer for question 1. The answer there is A into B. So you will work out number 2, 3, then we'll see how we get on. So 3. So these are the 2 questions that you're going out. So make sure go through those items and